Does anybody have questions for Mike? I think you fried a lot of brains with those equations, to be honest. I got about halfway through the second page, and I was like, okay, that's it. Just the brain cells quit by.
Well, that's what I was a little bit worried about when you asked me to present it, is because of the in-depth mathematics. But the end result is not that technical. When you compare the acceleration equation with the gravity equation, they fall out just almost perfectly.
Oh, okay, okay. Well, I'm really excited that you presented it, though. I mean,
Yeah.
there are a lot of different reasons that we're doing this conference. One of these is to get these ideas out there for people, to capture a legacy. Another part is to honor and respect the hard work that you and everybody else has been doing, right?
Well,
so
this was a 2-year study in 2 parts that I did for the Boeing company. It was presented both internally and then at the basically Glen's one conference. Both parts were presented there.
Oh, okay. Oh, there was SPECIF, right? That he mentioned there was 2 competing, and I remember that. I wasn't involved with it then, but there were 2 competing conferences.
I presented both of these at the first one was at Huntsville, and the second one was at the University of Maryland.
Okay. Well, so let's go to questions. Anybody, does anybody have their hand they want to put up, or?
I've got one.
Okay, go for it, sir.
Okay, so that in terms of the implementation of this field generator, effectively in the B field part of that, is that just a north-south type of cylinder magnet you could use for that system?
Well, the DC part would be, the AC part is a field pattern. One runs at 7 hertz and the other runs at 14 hertz. And they're all tuned and synchronized.
And then the ring that goes around the outside of that.
Oh, excuse me, you're talking about the application.
Yeah.
Oh, yes. Well, it's based on the same principle. Yes. So
effectively, I'm just taking a cylinder magnet, some kind of cylinder magnet, and around that I have some kind of a ring that has a strong electric charge on it, and I rotate that ring very fast, and then is that correct? Basically, the configuration.
Oh no, the magnet is an AC magnet, not a DC.
Okay, it's an AC magnet, and then as it's switching, because it's dissipating.
Yeah, and then by induction, you get the ring around there is conductive, so you would get an AC field induced. Like I said, it's an induction motor turned on end rather than rotating an armature. The whole thing is the armature, so it lifts.
Yeah, I definitely want to draw that up in a little bit more detail and have you look at that, so I can make sure I have the concept correct.
Is that a linear motor, basically?
Yeah, it's a induction motor straight off Tesla's design.
Jeremiah, we talked about doing this with Mercury. You don't remember?
So this is something a little different. He's talking about, no need for Mercury. He's got a switching B field, and he's got a E field that's being induced by that B field. It seems like it's not even powered. So this device doesn't require any mercury or anything dangerous.
Right. I'm saying with the same concept, just without the mercury.
It's way better because it's way safer, right? This is something that's a lot easier.
Well, it's a field generator. The beauty of it is one of the problems that were pointed out here about spacecraft is the accelerations you're going to get are horrendous. The solution is, if you use a field propulsion, the occupants are accelerated at the same rate as the machine, and you don't have the G-force problems like you do the way we do it, where you have an engine supplies thrust to the frame accelerates the chair accelerates the body. If the same field accelerates everything, then there is no differential, which is what we call, the force field. Then
I think there would be inertia.
Inertia. You could get by with a lot faster accelerations.
And Lorentz forces. Mike, you're still going to have the same problem with the fast accelerations and right-hand turns that'll kill people. You're accelerating the contents. You just admitted it.
Yeah, but they're all accelerating at the same rate.
So that's what
You're
just
saying
happened.
the
this
whole
past
frame
week
is
with the
moving
space
at the
station.
same rate.
Yeah, the space station had some astronauts. Now they're coming back today. You gonna tell them they're not being accelerated?
Well, they're being
Well, I mean,
decelerated.
theoretically,
I mean, decelerated.
there-
Oh, well.
there's
Anyway,
no
right
inertia.
now.
When you drop something, it's zero, then that's, you know,
It's
free,
the
that's why
weightless.
it's called free
Yeah,
fall.
when you drop it.
But you don't feel any force when you're
Yes, you don't.
dropping.
Yeah, if you're
When you
doing the
stop,
whole
it's
frame,
doing-
right?
Yeah,
It's
when you
stopping
stop.
that gets you.
You're moving in the frame with the frame when you're dropping. That's my point.
Well,
Yeah.
and that's what they were talking about with tic tacs too. That's how the
Yeah.
tic tac can do those maneuvers, because in their case, I think, what was the Sarfati was saying, that the warp bubble is the frame. Whatever happens in the frame, he was saying that there's no movement within the frame. It's the frame itself that's moving.
Yeah.
It needs to be
Right,
a
so you
speedo.
can take
Yeah.
the frame and move it to close to the speed of light, and it feels the same to you. But to someone looking at you from the
Bingo.
rest frame, you're gone. You're invisible. You've
Yeah.
exceeded the speed of light.
After you hit C, he don't see you anymore, but you can still keep going.
Yeah. You don't feel it because
No.
you're in the frame is moving with you.
Yeah.
Just like dropping in free fall.
Exactly.
Good
Yeah.
point.
Well, let me hear. I got a bunch of hands up. Let me go to Wayne first, and then I'll go to Will after that. So Wayne.
Yeah, hello. Just a simple question. Just wondering if you've been able to construct any prototypes.
Yeah.
I would love to when I finish working for
Oh.
Tom and when I finish working for Steve.
This
That is my next project, is to build a working model. Yes. I couldn't talk anybody at Boeing to let me build one there, so I'll do it on my own.
Would you be interested in working with anyone else to have that built if you could instruct on it a little bit? Because we'd like to, I know we have people on the team that would like to build it, that's for sure.
Well, yeah, so would I, but right now I kind of work by myself because it's,
Trust anybody else.
I got so many irons in the fire, and I was sick, and I'm about 2 months behind, and I sometimes don't know which end is up right now.
Yeah.
Well, teamwork makes the dream work.
Yeah.
I think what Jeremiah is saying is he has volunteer labor. So
Yeah.
Yeah, basically, and parts that you don't have to source or pay for. So I basically just kind of need a thumbs up and hey, I give you some advice on that if you want to build it.
and Wayne, your camera is being a little strange. In that, or you?
He's using
Okay.
the Tesla drive.
Yeah, there we go. Okay, he's because he was floating on the side there for a minute.
I got
Okay.
a virtual background.
Yeah, no, I was just teasing you. I was just your phone. You flipped the phone, but it had you.
Yeah. I'm
Yeah.
typing on my phone. That's why it's all weird.
Did you have any other questions, or was that everything for now, sir?
Me?
Yeah.
Oh, yeah. I mean, you guys are talking about being able to travel with no inertia. I'm just wondering how that principle, if you're doing some kind of induction motor kind of principle, it seems to me that would produce G forces or acceleration on a craft. So everything in the craft would experience those G forces.
Well, it would be the same force, so the delta is 0. Our basic system is totally different. We have separate components. You have the motor, the frame, the chair, and the passenger. And that difference due to inertia is what causes the problems. So if you accelerate the whole field, one shot, the delta is gone.
Okay. I see.
Okay.
Yeah.
Okay. Thanks, Wayne.
It's
Let
a
me.
little bit different thinking than the way we presently do it.
Yeah,
So
sure. Okay, I'm done.
thanks, Wayne. Sorry about that.
No worries.
Okay. Let me go to Todd next. Sir?
Yeah, hi. Could you show that slide for the warp drive application again?
Sure. As soon as I figure out how, hang on a minute. Share. This one?
The one with the ring and the magnet. And
Oh,
then
no,
the
that's
base
not,
magnet.
that was the Tesla one.
Oh, that was the Tesla one?
Yeah.
Sorry.
Okay, this one.
Yeah, that one.
Yeah. Okay.
So you had a top view, I guess is the next
Oh,
slide.
you want the top view? Okay, there's the top view.
Yeah, so what, is that a magnetic monopole? The way you have it drawn there?
Yeah, you could call it that. You're only the field is a dual because it's a dipole, but right now I'm just using one end of it.
Okay,
And the
that
reason
makes sense.
being, this generates a field that is centered at one end of the magnet or one end of the vehicle, whatever you want to call it, the top end. Now, if the center of the field and the center of mass coincide, which would be the center of gravity of the device, nothing's going to happen except probably generate more inertia. But if the two are not, if the center of force is higher or different than the center of mass, it's going to try and accelerate the center of mass to coincide. It's like the bone hanging in front of the dog.
Yeah, I've looked at solutions like this. So the electric current in the ring flows because the magnetic field is changing.
Yeah,
correct?
it's induced, just like electric motor. It's an
Yeah,
induction
so it's a
motor.
short circuit on a transformer.
Bingo. Yep.
Yeah.
Yeah.
Okay, so here's the what you're calculating on the force is just the E cross B Lorentz force, the current in the magnetic field, correct?
Yep.
Okay, so there's another counter force that as the current increases in the ring, it pushes backwards against the primary transformer magnet.
That's back EMF.
Yeah,
Yeah,
and the force is the opposite direction.
that's correct.
Okay, so I don't know, if there's a great big separation between the two, then you would radiate that in that field that's stored in there, and that could give you some thrust, but it's no more or less than a photon rocket.
Well, most of the photon ones that I've seen are all DC, which don't go very far. NASA had
Right.
the great
Yeah.
big one that generated what, 8 grams of force or something like that.
Yeah,
$1 million
no.
machine.
But yeah, but if you all I'm saying is that the forces almost cancel out, and the only thrust that's the difference between those two forces is the amount of leakage you're getting of the field out one side.
Well, that's true.
All right, so that's all. I wanted to say. It's not going to give you huge accelerations unless you're in the like multi megawatts.
Well, yeah, you're going to have power, but electrical power is a lot safer than sitting on a powder keg, which is the way they do it now.
Hell yeah. Hell yeah.
I
Awesome.
didn't say it was perfect, and I didn't say it wasn't going to be difficult to build, but it's far safer than sitting on a powder keg, which is the way we do it nowadays.
Yeah, if any kind of propulsion that could get us, significant amount of thrust without carrying propellant, it would be awesome. So
Yeah.
We're sitting on a cyclotron, not a powder keg, right?
Yeah,
all right, thank you.
you bet.
Thanks, Todd. Let me go to Will next. He's been very patient. Sir? Will? There we go.
Okay. Oh, okay.
Yeah, he's still okay, there we go.
Figuring out how to get it down. I'm not a
Anyway,
computer jockey.
Yeah, on slide 56, the slide before that, actually.
Oh, want that back up again?
Well, the red bar, can you tell me what that is again? Is that a coil, or is that like is it a solid?
Well,
So-
it would be an electromagnet is what that would be. There would be something magnetic, high magnetic permeability, and it would be operating AC. So
Okay, and then
it would be a
the thing
coil.
surrounding it is also a magnet.
No, that would be just electrical, be non-magnetic, like a copper bar or ring,
Okay, okay,
aluminum. All it does is carry the current.
okay, so you carry the current through the green one, and the center one is just a bar magnet,
Well, it's AC bar magnet, yeah.
AC bar magnet.
Yeah.
Okay, yeah, I just want to be clear on that.
Yeah.
Thank you.
Okay, thanks,
So,
Will.
I just did have a quick question. So effectively, the center of this thing, the ring and the magnet, the AC bar magnet, wouldn't that kind of look a lot like, you know, the ARV's core and the surrounding spinning conductive ring?
And Jeremiah, you might have to give Mike a second. I accidentally muted him. I was trying to mute Will when Will's finished, but Mike, you'll have to unmute.
I see it. Okay.
I'm sorry, sir.
Yeah, no problem. Wrong button. I'm used to that.
Oh no, the controls, it moves around based on where people are at in the screen.
Yeah, I know.
So, yeah.
And you punch it too soon and you get the wrong one.
Yeah.
Yeah.
I mean, what do you think about that idea, though? If the you know, if the disk of the ARV is spinning at high speed and there's a pulse magnetic field from a tall solenoid like magnet, you know, and its position, would that kind of configuration create, say, an acceleration field for everybody inside that craft?
Well, in theory, yes. Practicality, you're probably going to have to do some tweaking. I mean, the structure of the frame is going to, you know, re-radiate or reflect. So you'd have to, you know, build the frame to take that into account. But in theory,
like problems like inertial leakage, for example, that might kill the pilots. You know,
I mean, in theory, anything in close proximity should be receiving the same amount of acceleration or thrust or whatever you want to call it, both the frame and the occupant, in theory. Now, theories usually take a little tweaking when they get to the real world.
Well, I really like this theory anyways. I like where it's going, and I am quite curious to investigate it further.
Well, you and me both. I've been trying for 10 years to get Boeing to let me build it.
I'm sure it'll come sooner than you expect.
Well, I think Jeremiah's thinking about building it right now. I can see the wheels spinning. He's like, how could I do this? Yeah.
Oh, come on, I have to be thinking that thought. That's like why I exist on Earth.
Yeah, well, there you go. There you go. So, okay, well, let me ask who's next? Who has more questions for Mike? And then after this, I think we'll go to the Falcon Space. We'll go to Mark Sokol, and Mark actually he was going to work with Brian St. Clair, who's still with us. But Gravity Alchemist, sir.
Hello there. Okay, I want to get this last question in. Do you hear me okay?
Yeah.
Okay. Hey, Mike, you know, I saw you talk on one of the earlier conferences, and you know, all the stuff you're talking about today is way over my head, of the math and everything. Like I said, I'm not a scientist, but I listen to your whole thing. I look at all the numbers. I look at the pretty pictures. But you know, it's like 200 years ahead of what I'm thinking of. I have mentioned to the group that I'm just working on torsion, spinning things with electricity and momentums, equal and opposite momentums, spinning rings, spinning liquid. And I asked you the question about if you knew about liquid reaction wheels. So you answered that question for me, but this last question that I have for you, on these reaction wheels, when a satellite uses the reaction wheel and it begins to change its attitude, and say it begins to rotate around its center of mass, if you were able to desaturate that, you know, in other words, I know it stops, you're able to stop it, but let's say you can't stop it, and you saturate your reaction wheel. Now, let's just say you can desaturate the reaction wheel without making it go backwards or stopping. And you spin it back up again without a reaction to the satellite. But then so the satellite's now it's rotating. It's rotating around its attitude.
Yeah, okay.
And then you do the reaction wheel again. It'll just speed it up, and you can keep speeding it up as long as I think I have a way to get around the reaction wheel saturation problem and the changing the center of mass. I've got a way to get around that already. But my thing is, in other words, it'll keep spinning faster and faster.
Well, there's an energy limit that comes into play.
The gamma.
Well, I don't know about that, but it won't go faster and faster. It'll go up to a certain speed, and then unless you put more energy in, because the gyros can only supply so much energy, so there is a speed limit on it.
Okay, so it doesn't become relative. It doesn't reach a certain, like say you're doing.
Well, if you look at an acceleration chart, it's non-linear. You get a fast, and then it rolls off. When you start maximizing the energy, if you have a small wheel on a big frame, it's almost infinitesimal. You get nothing. You have to. I'm working on building a test article for Tom with scissoring gyros on there, and we had to increase the horsepower of the servos because the frame was too heavy for the smaller servos. Last time it just barely would move. Now I got it so it moves because we got bigger servos on there, which means we're putting more energy or power into the system. The frame or inertia of the frame has remained the same, but we increased the power we're supplying. So it now will work.
Oh, okay. So I guess I'm talking about in microgravity then.
Well, yes, but the
same thing?
principle is the same. If you had unlimited power, you would have unlimited speed. But as long as you have limited power, you have limited speed.
Okay, I'll research that some more. I'll look into that. I know there's a gamma factor involved in the equation, but I thought that when you get way up there around half the speed of light, that this it takes more energy to overcome the inertia whenever you're pushing an object.
Well, yeah,
or spinning it. In other words, torquing it.
Well, either rotating motion or linear motion, your speed limit is c. Yeah.
Oh yeah. Okay, but that energy factor doesn't really start going up until like you could go 13% of the speed of light without the gamma factor.
Oh, okay. You're talking about R versus RC.
Okay.
Yeah, or
Yeah.
V versus VC. VC.
Yeah, it's
the percentage of the speed of light. Yes.
Right. So in other words, if you could even go 13% speed of light, you could go around the Earth in 1 second. And we need faster
That's
spaceships.
what I was saying, that if using these EM drives rather than rocket propulsion or something, you're limited to the jet velocity coming out of the rocket. That's the theoretical maximum.
See, my idea is I go from a symmetrical steady state system around the center axis. Then I move the center axis, maybe say a few inches. And then I rotate the spaceship around that new center of axis with a certain process that I have. And so I moved 5 inches.
Yeah.
You would like my
next pitch.
Okay. Oh, okay.
It's on Dean Drives where we talk about this stuff.
Oh, okay. Dean Drive. Okay. I was hoping there was another segment to your teaching today. So
No. This has nothing with today. This is a complete different Some
Oh.
people thought that's what I was pitching today, but there was a
Yeah.
slight mix-up.
Yeah,
Next-
no,
Okay.
that's
Okay.
that's my fault. I should take responsibility for that. Mike sent me over, I think three or
Yeah.
4 ideas, and you know, and the way that he wrote the email, and he wasn't specific. So the way that he wrote the email, I was like, oh, I think he's talking about Dean drives. So
Yeah, we want the Dean
Okay.
drive.
Okay.
yeah, so that's
Well,
my fault.
I can't wait to see the
So the
Dean
video
Drive
can work.
presentation. I hope you do that soon.
Well, Tim's the one that controls that. When he says
Okay.
pitch it, I do.
Well,
I don't
yeah, I'd
think
be
the
happy to
Dean
have-
Drive works myself because I've
Oh,
looked at
no,
it.
he doesn't
but,
think it works.
That's just my opinion. But maybe I could explain myself and you guys could help straighten me out, or maybe, you know, we
Tom's
could learn
video would do you wonders right now on our little test article.
That's exactly what I'm doing this moment. Okay.
Are you- okay, well, yeah.
Here it comes. Sharing the screen. Okay, this is wonderful. Mike Gamble's amazing breakthrough with all kinds of.
Well, almost. That's with the old servos where it just barely moved. It does a lot better now.
The point is, though, it moves across a flat surface all by its lonesome.
That's right.
Look at that thing go. Woo! It's a race car.
If I get mine working, we'll race because mine is going to go to orbit from
All
launch.
right. Well, so is Mr. Boeing. He's
Oh.
ready to go to orbit too.
My dog's bigger than your dog. No, I'm kidding.
It's a race.
I love it.
Okay. Well,
You guys are
guys,
awesome. Thanks.
yeah, I guess I should ask if that's everything. We got about 3 minutes left. If that's everything for Mike, does anybody have any last minute questions, or are we all set, you think?
Yes. When do we get to orbit?
Soon.
I got a little work ahead of me yet.
Mars Direct. Mars Direct.
Okay,
5
well,
days.
yeah, let me do that then. So I'll tell you what I'm going to do is I'm going to put it back on gallery view. And everyone, please, one more hand for Mike Gamble.
Go, Mike, go.
Mike, thank you for an amazing presentation. And yes, Mike does. He has, I think, like 3 or 4 more presentations. The others take more time to set up, and so that was kind of where things are. But
Whatever ones you want me to show, I have a whole bunch of other ones that I didn't list, but I have all the generation of that test article from day one. It's been 4 years in the making.
okay, well, yeah, absolutely. Well, so let's do this now. I want to go. Actually, I want to go over to Mark, who's been patiently waiting there, Mr. Sokol. So let me mute. I'm going to mute Mike out, mute Gravity Alchemist out. Okay. And there you go.